Lecture 7.4, Conceptual Ranking, Circuit Question. Suppose these light bulbs can be modeled with fixed resistance with all resistor values being equal. All power supplies have the same voltage. Use conceptual ideas to rank the brightness of each bulb relative to each other, and 2, the power delivered by each power supply. Explain your reasoning using short, concise sentences. So when I look at these elements here, I'm going to start by picking maximum and minimum powers. I'm going to start by picking the easiest ones. So picking the maximum and minimum powers. So when I see when I think maximum power, I see that the bulb is parallel to the source. Then the reason why it's max is because we get max voltage and max current. So when I'm thinking the minimum power, I'm looking for maximum resistance to reduce current, and that typically means resistors in series. Let's start by looking at the maximum power. So these have to be circuits where they are in parallel to the source. So any element parallel with the source has max power. And when I come up to the circuits here, you can see that I have circuit 2, C and D are in parallel. And the other element that's in parallel looks like it's going to be H. So if I come in here and I get H, you could see that these guys are in parallel with the source. So why is that the case? There's only 2 nodes. So if I look at this guy, that's the source node, just like this one. So I know that that's the source, this is the source, and of course, this is the ground down here. So that immediately tells us that you're going to get maximum voltage, and that's the smallest resistance that you can have. So right away, we could see here that the power of C and the power of D and the power of H now have max power slash brightness. Now let's go look at the minimum power. So the minimum power is that if you come over here and you ask which one has the largest resistance. So if you look at A, B, they're in series, so that's going to give me the highest. If you look at 3, E is then in series with F and G within parallels. That F and G is smaller than B. So therefore, it has a lower resistance and it's going to get more current. So, but you could see that I and J are going to be the same as A and B. So writing this up, we then should say that we have circuit 1, right? So let's bring this guy down. And I should probably put that into words, is that the minimum power is the branch with the highest resistance and lowest current. And so we could see that one is going to be one of them, and the other one is going to be 4 here. Look at I and J. So if I copy these guys here, and I'm going to paste this guy right in here, here's what I'm going to find. I have 4, and I have 1. Actually, 1 looks like a 4. Let me clean that up a little bit. So this does not belong here. So when I'm looking at these guys, you're seeing that along this branch, right in here, I'm getting max resistance. And I'm getting along here, I'm also getting max resistance. So even though they have the same voltage here, you're finding that they're going to get the smallest currents. And therefore, they're going to have the smallest, the minimum of the powers. So right away, we could then say that the power of A, which is the power of B, which then has to be the power of I, which is then the power of J. So when I look at this, we effectively have what? We have dealt with A through D, H, and I and J. We have not figured out circuit 3. So let's go do that. So now our focus here is on circuit 3. So let's see if I can paste this guy. And here she is. Now, what I want to do is that I need to compare it to something. And so what I'm going to do here is that I'm going to compare this guy to this circuit right here. So if I compare these guys, what do I see here? Well, the one thing you want to pay attention to here is that look what's going on. Right in here, note that I have that this resistance, this parallel resistance is lower than a single bulb. Let me move this over a little bit. So if I compare, so look at that, E and A are the same. Now I'm comparing F and G versus B. So what this tells me here is that compared to circuit one, I'm going to say that this has a higher equivalent resistance, which then means there has to be less current. On this side here, we're going to have a lower resistance, equivalent resistance, which then tells us that we're going to have more current relative to 1 here. So when I'm looking at this, then I could start to compare the bulbs here. So let's look at comparing these guys. So comparing bulbs E, F, and G versus A and B, we have to say here that the first thing that we got to say is that there's more voltage across bulb E as than bulb A as well as a higher current. So I have more current flowing through this circuit 3. So if I compare E to A and to B, they're going to have higher power. So in this case, we're going to say here is that the power of E has to be greater than the power of A, which is also the power of B. So now let's go look at bulbs F, G, and B. Now what you're seeing here is that this is a smaller resistance. If it's a smaller resistance across F and G, and they're in parallel, they have to have less voltage. So let's look at that. So now you're going to have less voltage across bulbs F and G than bulb B. So in other words, this guy's going to have a smaller voltage than bulb B. Not a surprise. But now the current is coming, and what's it going to do? It's going to divide. The current divides into F and G. So as a consequence, what I'm seeing here is that since there's going to be less current through bulbs F and G, since they divide the current. So what that tells us here is that means that they're going to have, well, I already said it, they're going to have less current. So then if I look at the power, I would expect that the power of F, which is the power of G, that means I'm looking at F and G, they got to be the same. That has to be less than the power of B. So I would expect that the power of B to look just like this. So now I can do the overall ranking. The overall ranking of all the bulbs are, we see here that we have the power of C, D, and H. That's what we talked about before. And then the next most brightest one has to be PE. And then we have all the series ones. So we get A equals B equals I equals J. And then the ones that are the less dim is E and G, F and G. F is the same as G. Here are the rankings. So now the question is, let's go look at what PhET says. So PhET, that's that circuit applet. So I haven't turned on the switch for the PhET applet because it was using up a lot of man, it was a hog as far as using the internet. So let me go turn this guy on and change. So here I am. So here it is. So all I got to do is here is I just got to look at the switch here. So there's that switch. There's this switch, that switch, and then that switch right there. So what do we know? We said that the brightest ones were the ones that are in parallel to the source. So so right in here, that if you look at the second circuit, you could see that these two bulbs are the brightest. And what do we know? They have to have the highest current. And compared to all of the currents, you can see here that the current of these two right here and this one is the same. All of the other ones are slower. Now what we want to do is we want to go see which one is the next fastest. So I claim that it was E. So which one is E? E is this guy right here. And all I could say here is that look at the brightness. Look how bright this is. I would say that this guy has more lines than the one at A. And I would say that this one is brighter than the one at over here at, well, if I compare this to A and B, that's the same as comparing these two because they're in series with the source. So I would say that this guy is the second brightest. You know what? I'm just going to take an image and just take this in. So if I have my image, let me, so I just got the image and here it is. So if I look at this, what am I actually seeing? Well, a couple of things that we should label the bulbs again. So this is circuit number 1. This is circuit number 2, circuit number 3, circuit number 4, and then this is bulb A, B, C, D, E, F, G, then this will be H, I, J. So if I look at my rankings, just looking at the lines, we can clearly see that C, D, and H are the brightest of the bulbs. The next brightest, the ones with the longest line, has to be E. And that agrees with us. That's the second brightest. And then we got to go to A, B, I, and J for the third brightest. And if I compare A, B, I, J compared to F and G, you'll see that they're definitely brighter than F and G. So this agrees with our rankings right here. So now what I want to do is I want to go look at the power. Okay, I want to go look at the power. So now what we want to look at is the power. We want to rank the power delivered by the power supply. So let's go look at these. So I'm going to go up and I'm going to grab those circuits and bring them back down. So here's my circuits right here. And so now that I have my circuits, what do we expect to be the most powerful? What we expect to be the most powerful are the ones that are going to be that are going to have the highest current here. So if I look at this, I would say that definitely the most powerful has to be with circuit 2 and then circuit 3. No, not circuit 3. No, I'm sorry, I messed up. I'm saying here that circuit 2 is the most powerful. Since it puts out the highest current with the voltage source. So circuit 2 is definitely the one. So now the thing that we should do here is that we want to compare 1 to 3. So let's compare circuit 1 and circuit 3. So if I look at one, here's one. Now let's go get three. We want to compare these. And we want to do the same thing that we did before. So the power supply is going to have the same voltage. So we're going to look at the current. So if I compare these two, we've already had this discussion, but note the resistance in one is higher than the resistance of three. So the way we compare this here is that, look at that, A and E are comparable, so that's not the issue. The comparison has to be between resistor B and resistor F and G. So what I'm seeing here is that the equivalent resistance for circuit 1 is then going to be R1, which will be RA plus RB, versus circuit 3 has R3 is then going to be RE, but now I'm going to have RF and RG in parallel. But what I'm seeing here is that this is a lower than RB. Therefore, circuit 3 has a higher current since it has a smaller resistance than circuit 1. So right away, we can say here's that the power of circuit 3 is greater than the power of circuit 1. Now we need to compare 3 and 4. So I'm going to come here and paste 3 here. Let me go up and get 4. And then here's 4. So let's compare these guys right here. So here what we want to do is compare circuit 3 versus circuit 4. The first thing that I would note is that how do I compare the resistance? Well, these guys are in parallel. These guys, so we're going to say that these are in parallel. These are in series. But that implies that this has a higher resistance. This implies that it has a lower resistance. Therefore, it has a lower current and power. This one will have a higher current and power. So in other words, this is telling me that the power of 4 is greater than the power of circuit 3. So my rankings is that the power supply rankings are then going to be the power of circuit 1, which will then be greater than circuit 4, which will then be greater than circuit 3, followed by, oops, I put 1, and then we finally have circuit 1 as being the least. So how do we know this? Let's go back to the applet. If I go back to the applet, here's what I'm seeing. What we want to compare is that we want to compare the current coming out of the power supply. Each of the power supplies has the same voltage. Look at this current. Now compare to that current right there. I would say that this one's definitely moving faster. 2 is moving faster than 4. Therefore, if their drift velocities are different, then their currents are going to be different. So 1 is higher in power. This one is second. So now I got to compare 1 versus 3. It looks like 3 is flowing faster than 1. So therefore, 3 has a higher power compared to 1. That's it.